Math 3, Unit 9, Section 4. Today we're talking about factors of similar figures. Also today, sorry, I'm trying to decide what order I want to do things in. If you have your homework or if you don't, this first portion right here on your homework, we're doing in the notes today. So you can actually cross that portion out on the first page of your homework. And so on the first page, this is the only problem you're going to have to do here at the bottom. And then through the rest of the homework, you're going to do these word problems. And then number 7 is more of a challenge problem. And if you get it correct, you can earn extra credit. So that's that. All right. So back to notes here. We have these similar figures, and if you go to the chart at the bottom, and I think I'm going to have to do these notes on 2 pages. Hold on a second here. So your chart there at the bottom is asking you to compare figure 1 to figure 2. Okay? And so if you look here, it says height, perimeter, area, surface area, and volume. So there's a lot of work that we're going to end up doing for all of these figures because we have to find all of those things. So be thankful that you're not doing them on your own in your homework. Okay, so from figure 1 to figure 2, what is the height of figure 1? 12. So we're going to go a ratio of 12 to, and the height of figure 2 is what? 4. And you always want to reduce ratios to their lowest form. And so these can actually be reduced to be what? 3 to 1. Very good. Okay, so next we are going to, find the perimeter of both the figures. Okay, so figure 1, perimeter. So perimeter is just the outside, right? So not the 3-dimensional, but just the base, okay? So that means we're going to have 2 15ths. So if you want to, we can write it out. 15 plus 15 plus 9 plus 9. And that adds up to be?
48.
Very good. And then the perimeter of the bottom, the figure 2 shape, if we add that one up, it's going to be 5 plus 5 plus 3 plus 3, which is 16. Good. And so if we write this here, our perimeter is 48 to 16. And what can that reduce to?
3 to 1.
3 to 1. Very good. You can divide by 16 to both of them, and it reduces to be 3 to 1. Okay, then it says area of the base. Okay, so on figure A, I'm just going to put a big B for our base area. What would we multiply by? 15 and 9. So 15 times 9 is 135. And then the base area of figure 2, we would multiply 5 times 3, which is 15. So that means we have 135 to 15. And that can reduce as well. And actually, you can divide both of them by 15. And it reduces to 9 to 1. Okay, surface area. Do you remember how to find surface area? No, that's volume. So surface area, remember, is you're like taking the area of all the faces and adding them together. Do you guys remember that now? Okay, so surface area. So let's just start with the front face. Or we can, it doesn't really matter, I guess. If we started with the base, we have 15 times 9, correct? Okay, so 15 times 9, but how many of those are there? 2 of them. So I'm going to go 2 times 15 times 9. Is that okay? So that's taking care of 2 of our things. And then we're going to add it to, on the side here, this one is 9 by 12. So we're going to have 2 times 9 times 12. And then our front is 15 what? By what?
14 by 12.
Good, because this is also 12, right? And so we have 2 of those, which is 15 times 12. So here, 2 times 15 times 9 is 270, plus 2 times 9 times 12 is 216, and 2 times 15 times 12 is 360, and we add those all up together and we get 846. So we're going to do the same thing, surface area figure 2. I'm going to kind of move this up here so you can see on figure 2 what I'm doing. So we'll start with our base again, 5 times 3, but there's 2 of those. So we're going to go 2 times 5 times 3 plus our side here, 4 by 3, and again there's 2 of those. So 2 times 3 times 4 plus, and then our front is 5 by 4, so we have 2 times 5 times 4. Do we have questions on any of those? Okay, so 2 times 5 times 3 is 30, 2 times 3 times 4 is 24, and then 2 times 5 times 4 is 40. And that all adds up to be 94. So when we write that ratio, we have 846 to 94. And if I divide by 94 to both of them, they reduce to 9 to 1. Am I going too fast? Okay, last one, volume. And volume on a prism is pretty easy. We just have our base area. And didn't I already find my base area? It was 135. But I'm just going to go ahead and write this out as 15 times 9 is my base area times my height, which is 12. So 15 times 9 times 12 is 1,620. And then my volume for the bottom one is going to be my base area, 5 times 3 times my height, which is 4. And you multiply that and you get 60. So when we write this ratio, we have 1,620 to 60, and you can actually reduce both of those by 60, and you end up with a 27 to 1 ratio. Okay, questions so far? All right, so now we're going to do the same thing with our cylinder. Okay. So with the cylinder, the first thing we are going to look at here, and I'm going to fold this, is our perimeter. So, perimeter of the base is actually going to be what? Yeah, it's the circumference, right? And the circumference, which you need to remember. So I'm going to put perimeter, but specifically it really is the circumference. And so we need to just find the outside of the bottom, and that formula is 2 pi r. And so 2 pi times r, which is 6, means I have 12 pi. Okay, same thing for the bottom one. We're going to take the perimeter, which it really is the circumference. And so 2 pi r, which equals 2 times pi times 4, and that makes 8 pi. So we write our ratio here for the figures 3 to 4, and I have 12 pi to 8 pi. So first of all, do you guys notice how there's a pi on both sides? So those would cancel out, and then we can reduce both of them by what? 4. And so we end up with a 3 to 2 ratio. Very good. Okay, so the next thing we're going to find is the, oh, I didn't do the height. Oops. Okay, it's the same thing. Height is 3 to 2 as well. Do you guys agree? Like looking at your pictures, 3 and 2. Sorry. So, at least they're the same answers, right? Okay. Next, we're going to find our base area, and again, our base is a circle. And so, what's the formula for the base area? Pi r squared, very good. So that means we have pi times 6 squared, which is Tough one? 36 pi? All right, and then the base area of figure 4, again, is pi r squared, which will be pi times 4 squared, which is 16 pi. Good. So we write this ratio. We have 36 pi to 16 pi. And we can reduce that one by 4 and then pi, right? And so that one reduces and becomes what?
9 to 4.
Very good. 9 to 4 is correct. Okay, next we have surface area. Okay, so do you remember how we do the surface area of a cylinder? The outside is, and we know that that ends up changing to be like our rectangle, right? And then you have 2 circles on the top and the bottom. So we already found the area of the circle, correct? Yes? And so on figure 3, what was the area of the circle? 36 pi, but there's 2 circles. So we're gonna go 2 times 36 pi. Is everybody okay with that? Okay. Plus, and then we need to get the outer part of figure 3. When you undo it, I showed you last time, if you had a cylinder and you undo it, it actually makes a rectangle. But the height or length of our rectangle, however you want to think about it, it's really, let's think about more of the length. The length is actually the circumference, right? Well, did we already find the circumference?
Yes.
Yeah, what's the circumference? 12 pi. And so we're going to go 12 pi times the height, which is 3. And that gives us our surface area of the cylinder. And so 2 times 36 pi is 72 pi, plus 12 pi times 3 is 36 pi, and we add those together and we get 108 pi. Okay, so let's do the surface area of the bottom one. And normally I'd probably have you try to do this on your own, but for time's sake, we're going to just do it together. So again, we have 2 circles, right? And the area, did we already find the area of the circle? Which was it, what?
60 pi.
And there's 2 of them, right? Because you have your top circle up here, and there's also a bottom circle here. So that's why we're going to go 2 times 16 pi. Plus, and then this rectangle, the length of it is going to be what? Or the width of it? 8 pi. And so we have 8 pi times the height, which is 2. So 2 times 36 pi is 32 pi, plus 8 times 2 is 16 pi, and we add those together and get 48 pi. So we write this ratio, 108 pi to 48 pi. And that reduces to be you can actually divide by 12. Does anybody have a calculator?
Oh, it's 12.
It is 12? Okay, just making sure. Okay, and it reduces to be 9 to 4. Okay. All right, last one for this one is our volume now. So volume of the surface area is always base area times the height. Do I already know my base area? What is it? Good. 36 pi times my height, which is 3. And we multiply that, and I get 108 pi again. And the volume for my figure 4 is my base area, which is 16 pi times my height, which is 2, and that makes 32 pi. Oops. Okay, so when I write this one, I have 108 pi to 32 pi. And that one reduces to be, you actually divide it by 4 this time. And when you divide it by 4, you end up with 27 to 8. Are you guys noticing any patterns right now?
Yep.
Yeah.
The first 2 words base, the second 2 words square, and the last one's the cube root.
Does that make sense? And they're actually going to talk about it. But when you have like, you know how when you're doing perimeter, it's one dimensional, so your ratio is like where you have whatever numbers you start with are like 1. And then when you have area, it's 2-dimensional. And so you take these numbers and you square them. And volume is cubed. And so these are cubed. And it works on both of them. Okay, figures 5 and 6. Okay, so first of all, perimeter of your base. So this is a square. And so the perimeter of the base on figure 5 is going to be what? 30 times 4, which is 120. The perimeter of my base on figure 6, is going to be 12 times 4, which is, tough one, okay, 48. All right, and so here, don't forget to do the height. Oh yeah, thank you. Okay, so what's my height? 20 for the first one to 8, and that can reduce to be what? I agree. Okay, so the perimeter of our bases is 120 to 48, and what do you think that's going to reduce to? 5 to 2 is correct, because remember it's still like 1-dimensional. Okay, so whatever your height ratio is, your perimeter ratio should reduce to be the same. Okay, so if we were guessing, what do we think our area ratio will end up being? Squared. It's actually squared. So we think it's going to be 25 to 4. So let's go ahead and check it out. So the base area is what? My base area, it's a square. Do you guys agree?
Yes.
So we're going to go 30 times 30, which is 900. Base area of the bottom one is going to be 12 times 12, which is 144. So that means we have 900 to 144. And on that one, you can divide both of them by 24. And you could have like divided by 2, divided by 2, divided by 3, and gone through that whole process, but it ends up being 24. Okay, surface area. So for the surface area, we already know the area of the base, which is what? 900. And then we need to find the area of each of these triangles on the outside. So first of all, how many triangles are there? There's 4 triangles. And for the triangle area, its base, which is 30, times the height of this triangle, which is 25, and then you have to divide that by 2. So remember, triangles are half of squares, so it's always base times height divided by 2. I can actually reduce, 2 goes into 4 2 times, so I'm going to reduce like that. And so we have 900 plus, and 2 times 30 times 25 is 1,500. And we add those together and get 2,400. So now we're going to do the surface area of our figure 6. And again, we already know the base area is 144 because we already found that out. Plus, there are 4 triangles, and on this triangle, I'm going to multiply what numbers? 12 times 10 divided by 2. And again, I can reduce, and so we have 144 plus, and 2 times 12 times 10 is 240. And we add those together, and we get 384. So when we write this ratio, we have 2,400 to 384. And again, we divide by a whole bunch of numbers, but ultimately you're dividing by 36. No. This one we actually divided by 36. Sorry. This one we're dividing by 96. And what ratio do you think you should end up with?
10 to 4.
25 to 4. Good. Okay, and the last one, volume. This is where you kind of have a special formula for it-ish. And we have our base area times, actually not a special formula, base area times our height. What's our base area? 900. And the height of this figure is 20, because you're doing the height that's from the inside. And so we get the 18,000. Volume of the base figure, or the figure 8, sorry, is going to be our base area, which is 144, times our height, which is 8. Multiply those, and you get 1,152. And this can reduce, but let's say you don't know what it's reducing by. Do you guys know what it should reduce to be?
125 and 8.
125 and 8 is correct. And if you wanted the actual number it reduced by, it was 144. Okay, are we good with that? So we all see those correlations there? So it really depends on what you're working with, what the ratio ends up being, if it's going to be. So you can always take your height ratios, okay? And then based on if you're looking at surface area is when you're going to square it because it's two-dimensional. If you're doing volume, you know you have your cubes. So I always think because volume, I'm multiplying 3 things and I get volume cubed. So that means whatever my height was, I would take it to the 3rd power. If I'm dealing like with area, surface area, that's always ends up being squared. So I take my original height and just square it. So we don't actually have to go through this whole process every time, which is nice. Okay. So going to the back side, it asks you, using the table described, using the table, describe the scale factors below. So what is the relationship between one-dimensional and two-dimensional values? So one-dimensional means, and I just used A and B, but so one-dimensional is when you have like just an A value, where two-dimensionals you have A to the 2nd power. So what would be the relationship between one-dimensional and three-dimensionals? One-dimensional would be A. What would be three-dimensional? A to the 3rd. Good. What's the relationship between two-dimensional and three-dimensional? Good. And A to the 3rd. Okay. So based on that, we're going to complete this table, and you have a table similar to this in your homework, but it's not exactly the same. And so perimeter. Is this one-dimensional, two-dimensional, or three-dimensional? So that means if this is 1 to 2, this is also going to be what? 1 to 2. Area is what? It's going to be squared, right? Two-dimensional. So we're going to square it. And so 1 squared is 1, and 2 squared is 4. Surface area, is it one-dimensional or two-dimensional? I mean 2 or 3 or 1. Are we going to square it or cube it? Square it. So this will also be 1, 2, 4. And then volume, and you're always taking the original one-dimensional ratio. What's the volume going to be? 1 to 8. Okay, normally I'd have you do some of these on your own, but we're just going to kind of go through them quickly. And so height is one-dimensional, just as perimeter is. So that's going to be 3 to 4. What's area going to be? 9 to 16. Very good. So you're squaring 3 and squaring 4. Surface area will also be 9 to 16, and then what will volume be?
27 to 64.
Yes, 27 to 64 is correct. Okay, since this is two-dimensional, what would I do in order to figure out what the one-dimensional was?
You take the square.
Take the square root. So what are the 2 top ones going to be?
27.
Very good. And then surface area will still be 4 to 49, and then the volume would be?
8 to 343.
Good. Okay, the last one, we'd have to take the cube root of each of these, right? And so from there, going backwards, this one will end up being what? 1 to 9. And area will be 1 to 9, and then perimeter and height will be 1, 2, 3. Okay, do we have any questions? Okay, so now we're getting to the application part. Okay, This first one I actually think is one of the more difficult ones, but we'll go with it here. So the two boxes below are similar and both have to be wrapped with decorative paper. If it requires 4 yards of paper to cover the large box, calculate the amount of paper needed to cover the small box. So first of all, when you are covering a box, you need to think about what you would use. So what are you using when you're covering a box? You're using wrapping paper, but in terms of like, are you finding the volume? Are you finding the area? Are you finding the surface area? Are you finding the perimeter? What are you finding? Very good. So I'm going to write here surface area to remind myself that that's what I'm looking at here. So that means that once I end up getting my ratio, I'm going to end up doing what with those ratios?
Using the surface area.
I'm going to square them,
Yeah.
okay? So we take our heights. Do you guys agree? And so if we're going the big one to the small, so for my ratio, it's going to be 18 to 15, and what does that reduce to?
6 to 5.
6 to 5, because we can divide by 3. Now for this problem, because we're going to be dealing with surface area, that means I'm going to have to square the 6 and square the 5. So that means my ratio is really going to end up being 36 to 25 when I'm dealing with surface area. Is that okay? Because we're going to end up setting a proportion. Now, they said this box right here takes 4 yards squared of paper. This is in inches. That's a problem. This does not happen very often in your homework, just so you know. I just gave you the difficult one in your notes, because why not, right? Okay, so how many inches are in a yard?
12.
No.
No, 36.
Very good. Okay, so 36 inches is 1 yard. Are we all okay with that? So, finding the surface area, okay, in terms of inches, okay, we are going to take 36, because that's 1 yard, right? So we want to find how many inches are in 1 square yard. Are you guys with me? And so what you would do is go 36 times 36, and then we're going to multiply it by 4 yards. Okay, because they already told us that there's 4 yards, right? Okay, 1 yard is 36 inches. So in order to find 1 square yard, you would have to multiply 36 times 36, because that would give us a square yard. And since there's 4 yards, I'm going to go 4 times 36 times 36. Okay, so when you multiply all that, you get 5,184 inches squared. That's how many inches it took to wrap that box. Yeah. Okay, so now we're going to set up our proportion. Okay, you guys ready? So I'm going to go my big box over my little box, right? This is, we already found that ratio at the beginning, equals, this is my big box, right? 5184? So we're going to go 5184 over, and I just put X, because that's my small box. Then we just cross multiply and solve for X. So 25 times 5,184.
Times or divided?
These are multiplying. 25 times this is going to give me 129,600 equals 36x, and then you can just keep that number in your calculator, divide by 36 to both sides, and we get that x equals
3,600.
3,600 inches squared. Okay, and if you wanted to end up changing that back into square yards, you would have to divide it by the 1,296. Because 36 times 36, just so you guys know, that was 1,296. So if you did that, you would end up finding that it's 2.78 yards squared. So either one of these answers is really acceptable, but since they originally talked about square yards, it's usually a good idea to put it back into square yards. Okay, ready to do the easier problems now?
Yes.
Okay, so the figure to the right is 2 shampoo bottles that are mathematically similar, And the cost of the shampoo depends only on the volume of liquid in the bottle. If a small one costs $4, what should the large one cost? First of all, what am I dealing with in this problem? Cost and volume, okay? So specifically volume. This is going to be a volume problem, which means that once I get my ratio, we're going to do what to it?
Cube it.
Cube it, exactly. Okay, so it depends on how you want to write your ratios. It doesn't matter if you use small to big or big to small, you just have to stay consistent. So I'm just gonna, because of how it's written, I'm just gonna go 18 to 27. And what does that end up reducing to?
2 and 3.
Thank you, 2 to 3. So when I'm finding my ratio of this, I'm gonna go 2 cubed to 3 cubed, right? Because we are dealing with volume. And 2 cubed is
8,
8, and 3 cubed is
27.
27. So my ratio of small over big is 8 over 27. And then we're dealing with our cost, which would be what? $4. Is that going on, is it going to go on the top of my ratio or the bottom? Top. Why top? It's what the small one costs, right? And so we are going to, and if you wrote yours differently, then it would be on the bottom. But so that's 4 over x. And then we solve this the same way. We cross multiply. 8 times x is 8x. 4 times 27 is 108. We divide by 8 to both sides, and we get that x equals $13.50. Okay, questions? All right, last one. The cylinders to the right are similar. The volume of the small cylinder is 12 cups. I'm just going to write 12 cups here at the volume of the smaller one. And you could have even labeled this other one, $4 for the small one. Find the volume of the larger cylinder. First of all, what am I dealing with?
Volume.
Volume. So we have volume here. My original ratio is what? 5 to 25, which reduces to 1 to 5. But since I'm dealing with volume, what am I going to do? Cube it. 1 cubed to 5 cubed. So we get 1 to 125. Okay, so when we write our ratio, what am I going to write? Equals
12.
perfect. We cross multiply. 1 times x is x. 125 times 12 is 1,500 cups cubed. Okay, any questions?